doing? Okay, there we are. Okay, so what is this number? What number do we think this is? If I have this number, we have 60, right? No, not 60. We have 600. That's 600. Whoa, almost, almost. We have this one. You have 2. You got almost got it. And then you have 8. Thank you, user 979. Yes, yes. 628. Well done. Well done. Uh-oh. Okay. Right? Great. Uh-oh. What are we doing? That's not right. Back. Profile. Sorry, looking at my. There we go. Okay. Do this one. Okay. So what we're doing, I'm sorry. I'm just fixing my stuff. Okay. So we have, yes. So we have 628. We have 628. Thank you so much. Thank you so much. Okay. So what's our next question? So we have hundreds. This is my tens, and then this is my ones. So if I looked at it, 1, 2, 3, 4, 1, 2, 3, 4, this is 400. And then this is 5, 6, 5, 6. This is 60. And then we have 5, 6, 7, 8. 5, 6, 7, 8. Yes, thank you. User 979. Yes, 468. Thank you. Thank you. Thank you. Great. Okay, so we have 468. That's what 468 looks like. 468. 1, 2, 3, 4, 60, and then 8. 5, 6, 7, 8. And now we're on to our next question. What number do we think this is? If we have that number, we have our hundreds, we have our tens, and then we have our ones. So what number do we think that is? Oh, user 979. Well done, well done. We have 300, 1, 2, 3, 0, and then 5. All the top beat is a value of 5. Ooh, Courtney. So when we do 1 looks like this. 301. That's what 1 looks like. But this one is 305. Good job. Well done. Good. Good. 305. Does that make sense? Okay. So when we're looking, all the top beat is a value of 5. So when we're looking, we have 1, 2, 3, 300, and then we have our tens, and then we have our ones. What number is this? What number do we have? Yes, thank you, Courtney. Right? Easy. 366. Thank you. Thank you, Paper. Thank you, Bear Lover. Thank you so much. Yes, thank you, Paper Ghost. Snow a ghost. That's funny. Okay, so that is what it is. 366. And so what's our next number? What is our next number? If we have our hundreds, that's my hundreds. This is my tens. And then this is my ones. What are we doing? We're learning how to read the abacus. When we learn how to read the abacus, then we're going to go into adding and subtracting. Ooh, almost. We got to remember this is the 5. Yes, thank you, user 979. So we have 589. 500, 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Yes. Hey, Melinda. How are you today? I haven't seen you in a while. Oh my goodness. I thought you were somebody else and I thought you changed your user profile. So I kept calling you by user because I thought you wanted privacy. But then I see your profile. I was like, oh, I see you. I see you. Welcome back. Okay, we're almost done. We're almost done. And what are we going to do? We're going to do hundreds. So this is our hundreds. This is our tens, right? And then this is our ones. What number do we think that is? Yes, 278. Good job, 979 and Courtney and Bear. Oh, that's good. Hopefully he's okay, right? It's a good, exciting job. 200, right? 1, 2, and then 5, 6, 7, and then 5, 6, 7, 8. Yes, 278. Well done. Well done. And then what are we doing? What number is this? This number is, we have hundreds, we have tens, and we have ones. Doing well. I to see the number Bames. But I don't know what you're trying to say. To see the number. Oh. Hold on. I got it. This one, right? Like that? There we go. Yep. 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 So we have hundreds. What do we do? 869. Yes. No, thank you. I appreciate that. Bames. Right? So we have our hundreds. Yes, thank you. It's 869. 5678, 660, 56, and then ones. 5, 6, 7, 8, 9. Welcome, everybody. Thank you. Yeah, I'm doing well, Melinda. I've just been publishing out more books and everything. This is the other book that I want to publish out. This is the 3-digit abacus. So what we just did is we just did the maze. So that's what the maze looks like. Let me change that. Yeah, thank you. Oh, yeah, not a problem, 979. Not a problem. I appreciate all the support. I try my best to try to make sure that I get it out. But thank you. Thank you for, I hope it works well for you. And then because I run out, I gotta get some more. Hey, Jeffers, Jeffers, hilarious. Thank you, Jeffers. Yes, your abacus is out too. It should be on its way. Hopefully, you get to see it. So, okay, we are done. Are we okay with this? Should we do some more? We're gonna do some adding and subtracting. Thank you, everybody, for joining. I want that book. You want this book? I'm still publishing it. I got to make this book. Yeah, it looks like it'll be the third. It'll be here. Oh yeah, That's fantastic. Oh, 217. Melinda, you're so funny. Yes, you're right. It is 217. But I was going to do some adding and subtracting. Are we ready for some adding and subtracting? All right. So the first thing we're going to do is we're going to understand. I'll get it on the third. Oh yeah, you too. That's cool. Okay, so the first thing we're going to do is we're going to understand how to read the abacus. We already did that. We already understand how to read the abacus. And then I'm just going to do a review. So let's do a review. We talk about 1, 2, 3, 4. You might be asking, right? You might be asking, why are we here? We're here because you see this dot. This dot tells me my ones indicator. Yes, I want. Oh, hey, Adina. Welcome. Thank you so much for joining. So what we're going to do is we're going to understand you could choose any one of these. Because you could choose any one of these, we can choose this one. If I choose this one, then just as Johnny Boy had mentioned, I do have these tabs. And so what I would do, this would be the ones. So then we would call out, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this would be 10. Just like here, it would be 10. However, the problem is now we don't have any room for hundreds and we don't have any room for thousands and 10,000s. Oh, Melinda, I got more. I got more sound effects. Oh my god, it's so funny. All right. So we have 10 and then 11, 12. So again, we don't have our we don't have our third column. We don't have our hundredth column. So when I would choose this one, do you see how there's a dot here? So when I look, I can actually use this one, and then I have my 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 10. But now I could do hundreds. So we have 10, 110, 111, 112, 113, 114. How are you so? Oh, Johnny boy, I'm just very familiar with this because if you really think about it, I've been teaching abacus for 20 years. So, of course, you're going to be unfamiliar. Don't worry, it will happen. It just takes time. Don't worry. So, you just, take time to understand. So, when we're looking, we have this number. This number is 200 14. And then we can do this one, 221. So what we're doing is again just confirming how we're going to read the abacus. We have our ones, or you could choose this one. But notice if I have my ones here, now I have thousands. And then if I really choose to, I could do 13 columns. So if I have a 13 column abacus, I now have many different places to choose my ones column. So I could do here ones, right? Ones, and then because this is grouped by threes, we have our ones, our thousands, our millions. Oh, maybe I need a different one. There we go. Here we have our ones, our thousands, our millions, our billions, and then we have trillions all the way over here. But if I choose this one, then all I got to do is move everything over, and I have this. I have my ones, my thousands, and then my millions. Just like that. Easy, easy, easy peasy. And so that's what we're doing. And then if you notice, you will be able to utilize the beads because this is a standard size abacus. Because it's a standard size abacus, you'll know that it's easy to move. You just want to use the edge of the beads to move. So when we're looking, we want to be gentle when we're moving the beads. We don't want to be aggressive, right? We don't want to be mad. We want to be happy. We want to be happy when we're reading the abacus, when we're doing the abacus, right? So, so what does that mean? Well, when we're happy, right, it's easy and we're going to go with intention. You don't want to flick too hard. Don't flick too hard because then your answer will become wrong. What grade is a good age to start your kids on it? Well, I tried to create a book for preschoolers. So this book specifically is I was trying to gear it towards preschoolers ages 3, 4, and 5. So it all depends on what we're trying to how old the kids are, but that was my goal. My goal was trying to get them young. And they're available. Where is it? Where are you? I had it. Did I not bring it? Oh, boo. Okay, it is available in my TikTok shop if you're looking for it. Okay, so edits, you don't know what you don't know. It doesn't make you slow. Exactly, right, Adina? It's all about being familiar. Right now, we're being familiar. We're familiarizing with our abacus. Exactly, exactly. My dog is, oh, yeah. Is it just for adding and subtracting? No, actually. We go into, we can actually do multiplication and division. But for right now, we're going to do adding and subtracting. So the first thing we're going to do is we're going to understand how to add and subtract. So what I want to do is I want to show you how easy it is to add and subtract. And dividing. Yes, thank you, Melinda. And dividing as well. My daughter is 7 and she's liking the learning. Oh, nice. Very nice. So what we're doing is we're going to understand in the abacus world, we're going to be process orient, have a process orientation. I was reading this one book called The Toyota Way, and you know how everything is more efficient in Japan. So I realized what we do in mainstream math, we are result oriented, but we need to be process oriented because it's all about the add-in. It's all about the process. It's all about what we're trying to do. So when you look at it, we're going to look at the how to add the one. When we add the one, we have 5. This is the question. We have 5. We want to know, can we add the one? Yes. Yes, we can. We can add the one. So all I got to do is add the one. This is very specific. Yes, I need process oriented math. Show me the slide rule. Yes, we can, Jeffers. I don't know how to use a slide rule. That is above my pay grade. So my answer is 6. What do we have? We have 5, 6. So again, when we look at it, we can add the 2. When we add the 2, again, the question is can we add it? Yes, we can add the 2, and there you go. I have 8. 5, 6, 7, 8. But wait, there's more. So if you look, when we add the 3, the question again is I want to add the 3. I have 5 and I have 3. 1, 2, 3. I'm going to add it, and my final answer is 8. When we're looking in mainstream math, you could do the dots if you really wanted to, and then you would have to combine all the dots. So I think I should be like this instead, right? And then we would do this 1, 2, 3. Then we would have to count 1, 2, 3, 4, 5, 6, 7, 8. But if you notice, it's very easy to supersize on the abacus. Why? Because we know that this is 5. And then when you add the 3, we know that this is 8. That's how I learned the dots on the numbers themselves. Yeah. See? See, I don't know. Yeah, there was another one where they do like dots on it. It's like, all right. So again, when we're looking at the 4, we want to know, can we add the 4? We have the 5 and then we add the 4. Yes, we can add the 4. If not, we're going to take away the 4. Now you notice that my final answer is 5. And what we're doing is we're adding. When we add, we go to the horizontal bar. This horizontal bar is what's being counted. Do your workbooks use dry erase markers? This specific one does not. I do have this one that I am selling that is a dry erase. I didn't think that anybody wanted dry erase, but this would have been like, this is a pretty hefty book. This one is, we're going to be talking about the formulas, and I'll show you how to do it. But I do not use the dry erase here. This is actually just regular paper. Uh, is that something that you're interested in? Is a dry erase workbook? Because then you would only be 5. But I have like a bunch of books. So my books, this one specifically is about 200 pages. The next book that I have is, and I was trying to guesstimate, it's about 100 pages. The reason why is because I added in extra practice. So you have the lesson, and we're going to go through it. I'll show you what I'm doing here. But I have the lesson. So the lesson is learning the how to add the 1, how to add the 2, how to add the 3, and how to add the 4. And then the questions themselves are curated for the specific lesson. So this one specifically is how to add the 5. And when we do it, we have mazes, we have color by number, we have more color by number, and then what do we have? We have tic-tac-toe. So you put in your O, right? And then you answer the question. And I just did this one, right? But then you can add it, right? So that's what it is. And then what are we doing? And then we have the number bonds, and then I have here is the word problems. This one is the hidden word, so answer the question. But again, if you notice, it's very specific to the questions themselves. And so what I do, and then after that, after you learn how to add, we will learn how to subtract. Okay, so let's go back. Let's go back. How do you count to 10 using one bar only? You can't. You have to use 2, because just like how we write 20, right? We need 2 columns. We need 2 and a 0. So if we did 10, it'd be 1 and a 0. You can't write 10 with one number, if that makes sense. You need to have the second number. Thank you, Jeffers. Every number is a 9. Just how we write it. We have 2, right? 3, 4, 5, 6, 7, 8, 9. And then we have 10. 10 is our tens and our ones. Tens, ones, and tens. Just the same thing with the place value. So, I'm sorry. So I do a lot myself with my kiddos. I think abacus. Oh, it is a great tool. It is a great tool. It is a great tool. Let me continue with adding and subtracting, and I'll show you. I will show you. But wait, there's more. Yeah, it does. But the blues are tens. Oh, I see. So, Jihad, you're talking about the Chinese abacus, and that's when you get the 10. I'm not teaching the Chinese abacus. I'm teaching the Japanese abacus. So when we're looking, we have 1, 2, 3, 4, 5. And then because we have 5, we want to trade it in, and that would be 5. And then we have 6, 7, 8, 9, 10. Because we have 10, right? We want to trade this in to this. So this is 10. But the problem is we got to trade it in. So then we got to do this. 10. And now we have 10. On the Japanese abacus, it's kind of the same, but not quite. We have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. Yeah? Yeah. That's why my Chinese friend said it was different abacus. Yes, it is a very different abacus, but the rules and the formulas are very similar. Okay. How do you know? Okay. Yep. Okay, good. Yeah, we're okay. Good. Thank you, Jihad, for the clarification. I do appreciate that. Yes. So that's how we do it. And it works. It's really quite interesting. So when we're looking, we could do 6 times 1, 6 times 2, and then we trade this in for this. So we have 12, 6 times 2, 6 times 3 is 18. 1 and 8, 5, 6, 7, 8. And then 6 times 4 is 20. So we add that. So it'll be 24. It's really quite interesting. So anyways, How do you use them all from right to left? Oh, what is going on? I am so sorry. Hold, please. Wow, this is not working. Okay. Sorry, what was the question? We are practicing the Japanese abacus. Yes, we are practicing the Japanese abacus. Abacus. Yes. Sorry, I apologize. I'm also trying to stream on other places, but I found that this is not working. All right. Use view tab streamer. Okay. So what are we doing? What we're doing is we're adding. When we're adding, you'll notice we go to the horizontal bar. This horizontal bar, I was asking if they were all read from right to left. Well, yes, just like we write a regular number, right? We have ones, tens, hundred, thousands, 10,000. It's exactly the same. So when we're looking, we have our ones, tens, thousands, ones, tens, hundred, thousands. Does that make sense? The system was like holding up. She's teaching too much to the masses. Yeah. Does that make sense? So the way we write is the way we read it. Yeah. Okay. So what I'm doing is I'm going to continue on. When we add, we want to go to the horizontal bar. When we subtract, we want to go away from the horizontal bar. So notice, right, what we did is we added, and now we want to do is a take away. When we take away, notice we're going to be taking away the 2. When we minus the 2, it looks like this. I want to add the 3. I'm going to add the 3, and then I take away the 2, I'm going to take away the 2. So notice when I added the 2, take away the 2. You know how to add, you know how to subtract. So that's what it is. But remember, we're always looking at the number that we're doing, right? It's not what's the result, it's what are we trying to do. So because we have this, we want to be able to either subtract it or add it. Okay. And it's the same thing. So we do 2, we do 3. We have 4. This is 4. We add 4 to the abacus. When we have 4 to the abacus, what do? We want to take away the 3. When we take away the 3, we're going to remove it. We're going to subtract the 3, and that's what we're going to do. Does that make sense? So let me know if you have any questions. I do appreciate all the comments of the questions because it's really fun. It's really fun that I'm not the only one in the room. So we have 9. We have 9. And what we want to do is we want to take away the 4. When I take away the 4, all I'm doing is I'm going to take away the 4. Can we do it? Yes, we can. Do you think the Japanese version is more efficient than the Chinese one? Also, can we see a multiplication usage? Yes, we will do the multiplication in a little bit, but the first thing we want to do is understand how to add and subtract. If that's okay, we can put a pin on it. I think it's more efficient because in the Chinese one, it's a little bit more redundant. And if you notice, it gets a little confusing. So you have to do a lot more trading. So there's extra steps. I feel like there's extra steps because we need to trade it in order to align for the place value. Because the way the abacus is every column is a place value. So when we do this is actually 15, but it's a little confusing because we can't see it. It's too much for the human eye. Then we have to do this. We have to trade this into the tens, and then that would be 15. And then I do this. That's what I would do. So, do I have a multiplication book? Not yet. I have three times table, but not yet. Yeah, right? Yeah. Some people do appreciate the Chinese abacus. It's easier. Do you think the colorful one is easier for elementary school to learn? You know what? it it depends if you like the colors. That's all it is. It works exactly the same as the brown ones. I use this one for the younger kids because we think that young kids like bright colors. I use the bright one because it's easier, it's nicer on the video. It might be overwhelming. I don't know. You know what I mean? Just depending on the kid. So sometimes doing this one because it's 13 columns, a single color would be sufficient, as well as it won't be so overwhelming. It's up to you. I use the this one for the younger kids, and then I graduate them to the bigger one. But you can do exactly the same from this one to this one. The only difference is because size matters, the amount of numbers you can use. So when they get older, like when they get to grade 4, grade 5, I would transition them to 13 columns, if that makes sense. Um, Hello, RTX. Size matters. Okay, I got jokes. I got jokes. Okay, so what we did is we're adding and subtracting, and then elementary school, and then yeah, thank you, Adina. Not a problem. Not a problem. Um, so yeah, so I have a 13 column one as well. They work exactly the same. We could do the same thing, right? We could do 5, 6, 7, 8, 9, and it works exactly. You just need to choose one number, one dot. It doesn't matter. So what are we doing here? Is we're also continuing on subtraction. Notice when we add, we will subtract. When we add 6, we're going to add the 1, and then we add the 6. Remember, we're going to be big people, and we're going to add the 6 like this, right? We take away, we add, and now you're going to see that there's a number pattern. Thank you, miracles, for the heart me. So when we're looking, we want to add and we want to subtract. We want to add, we want to subtract. Does that make sense? The clacking sound got me to follow. Okay, so and then now that's what it is, right? We understand how to add, right? We want to go to the horizontal bar. When we subtract, we want to go away from the horizontal bar. And it's the same thing. We have 7, we want to take away the 6. We have 9, right? 9, and then take away 9. Add the 9, take away the 9. And you'll see that it's very similar to all the number patterns. The number patterns are very, very familiar. Yeah, right? Okay, so that's the thing. What happens when there's not enough? Now we're going to get into understanding what happens when there's not enough. What do you mean? Well, in school, we're teaching the kids how to use this equation, right? How to use this. But what are we doing? What are we doing? We are going to power it up. Now this is what I was talking about, the book. The book was how to make a 5. Now what are we trying to do? We know how to add, okay, but notice that the questions are very specific. These questions are very specific, and there's a structure to abacus. I have my yes. There we go. Okay, the structure is very specific. So if you notice, when I was adding the 3, I would add a 5. Do we have enough? Yes, we have enough. However, now we get to the point where we need to add the 4. If I look at it and I want to add the 4, can we do it? No, we cannot add the 4. Now we understand why we need to know the add-in. This add-in is what we're trying to understand. What are we trying to do? In school, we're telling the kids to memorize. That's it, just memorize. But let me show you. Let me show you. We are going to do this. So if you notice, we have 3. I have 3 on the abacus. When I have 3 on the abacus, I have 3 pennies. We know that these are 1 cent. Because these are 1 cent, I want to add the 4. But you know what? I don't have enough 1 single pennies. But you know what? I do have 5 cents. Because I have 5 cents, it's more than enough. I'm going to give you my 5 cents, but that's too much. I need change back. Give me some change back. So I'm going to take away the 1. So my final answer is 7. 5, 6, 7. We can do it again on the abacus. We can do 5 and then take away the 1. So what did we just do? We did some. So again, what I'm just going to do is rewrite. We had this equation, right? We had this formula. We had this addition sentence. 4 plus 1 is equal to 5. We isolated the variable. We want to add the 4. We substituted the 4 with this 5 minus 1. And then we added it in. So basically, in order to add, you need to subtract. Exactly. You need to understand how to balance the equation. So that's what we did. It was we balanced the equation in order to utilize this 5. Because if you look, let me do it again. If I did this one, right? If I did this one, it'd be 4. I have 4 on my abacus. I have enough. I need to add another 4. We're not memorizing 4 plus 4. What we're going to do is we're going to understand and utilize this 5. I have 5 cents. I have this nickel. I'm going to give you this nickel, but it's too much. I need change back. So there's a give and take. Because there's a give and take, the kids will understand that they add, they subtract. So it's very easy for them to add and subtract, right? I know in kindergarten they have a problem with subtracting, but in abacus it's part of the system, it's part of the methodology. So I'm going to add the 5, right? I can show you what I did here. I can add the 5, but that's too much. I'm going to take away the 1. So now we're balanced. Does that make sense? Thank you, Unhinged, for the finger heart. Yeah? Is that making sense? We could do it again. But see, every time I do it, we're practicing. And every time I do it, we compound our information. We compound the skill. So what we're doing is we're practicing the same concept, but in different form. And it's not 10 different strategies for the same number, if that makes sense. And that's what kind of makes me mad about mainstream math, is that we keep giving the kids all these other strategies to do things, and yet we don't give them the basics of what we're trying to do. So you get the point where, do you get to the point where the hand motion, yes, it becomes automatic, just like practicing a piano. I heard, does anyone know the origins of the abacus? I heard, yes, it's Mesopotamia. Like before Christ, kind of a thing. But it's like playing a piano, right? When you play the, you know what? Even better. It's like typing on the keyboard. When you type on the keyboard, you do it enough times, you know where your numbers are, right? You know where your keys are. You know where your letters are. So it's just like typing. Like I know I can do like a 9 digit typing thing. So, and that's what it is. Yep. Can I do? Can we put a pin in that? Let me put a pin in that. Let me write it down and put a pin in that. The reason why is because we're going to talk about the next one. I need to find um where is my paper? Oh, here it is. Yep. Can we put a pin in that? The reason why is because this has to do with a different formula. Yeah. Okay. So we understand how to add the 5. Yeah. Are we okay? If we're okay, then we can go to the next one, which is the next one. But let me continue on with like some more examples. So if I have 3, I have 3 on the abacus. 1, 2, 3. And notice I have 3. I have 3 on the abacus. I'm going to add another 3. But if you add another 3, I only have a nickel. I only have 5 cents. I'm going to give you my 5 cents, but that's too much. I need to take away the 2. So I'm going to add the 5 cents, but that's too much. I'm going to take away the 2. Does that make sense? Are we okay? We can continue on, or we can go to the next thing. How are we doing? You want to go to the next one? We can go to the next one. Adina asked the question. And before I forget, because we know how to add, we know how to subtract. I know Jeffers can do it. Jeffers, thank you for so much for the comment. Thank you so much for confirming. I do appreciate it. I really do. I'm thinking I'm sorry. Okay, good. Okay. Before we go, one more thing. So here's the one more thing. Here is minus. Again, you will see that there's a number pattern, because I really think it's the greatest thing next to sliced bread. It's the number pattern, right? So if we're going to add the 8, we add the 8. What are we going to do? We're going to subtract the 4. When we subtract the 4, notice we're going to take away the 5 minus the 1. This is the number pattern that you will see, and the kids will see the number pattern. So we add the 4, we take away the 4. Add the 4, take away the 4, right? Does that make sense? What do you mean? Are we okay? How's that working? Because that's the greatest thing, right? Because we add it, we subtract it. We know how to add. It's the opposite. So we do 16. We could do 16. When we want to take away the 4, guess what? Minus the 5 plus the 1. Minus the 5 plus the 1. Minus the 5 plus the 1. I think you made me laugh. Right? So we have 12. Our final answer is 12. We could do it again. I have 15. Is there enough to take away the 4? No, there's not enough B's to take away the 4. So what are we going to do? We're going to minus the 5 and plus the 1. My final answer is 1. Does that make sense? So you know when we add, we can subtract. That's it. We can do it one more time, and then we'll carry on to the next concept, which is 7. So we have 7 on the abacus. When we have 7 on the abacus, we're going to take away the 3. Guess what? We don't have enough to take away the 3. What are we going to do? We know to minus the 5 plus the 2. So my final answer is 4. Make sense? So that's what we're doing. And you'll see that it's the same thing. It's the same thing. The concept, right? You see the number pattern. We have 16 and then take away the 3. When we take away the 3, there's not enough. There's not enough to take away the 3. What do? Minus the 5 plus the 2. So my final answer is 13. Yeah, subtraction is absolutely more confusing on the abacus. Oh, no. No, it's exactly the same. It's just the opposite. That's all it is. Don't forget, this is also very unfamiliar as well. But when you see the pattern, you'll know to do the opposite. You add the 4, you take away the 4. You add this 3, you take away the 3. What do you think, Jeffers? What do you think? Is it more difficult? Subtraction in itself is difficult. That's what I think. Okay. So now we're going to do, right? It's the same thing, just the opposite. Yeah. All right. It is. It's exactly the same thing, but the opposite. Yeah. Right? Okay. We're okay with the 3s. We're okay with the 5s. But guess what? I'll tell you the secret at the end of this. This is the greatest thing. I'll tell you the secret. But before we go on, we got to keep going. All right. So that's what this is, right? This is just erasable, dry erase, and we just talk about the formulas. So we're adding and subtracting. It's the hand movements yep, exactly. It's the hand movements of the opposite direction. So we have 16. We want to take away the 4, and we want to add the 4. We want to take away the 4. We want to add the 4. That's it. That's it. Okay. So let's do another one. Let's do one more thing, and then we'll go into some multiplication. Why? Because this is the other pillar. The other pillar is what? We want to add the 8. Let's do 8. The question is what? I want to add the 4. There's my 4. 1, 2, 3, 4. Oh, you know what? I still need my coins. So what's going to happen is what? I want to add the 8, but guess what? That's too much. I have 4. 1, 2, 3, 4. I need to add the 8, but I don't have any more beads to add the 8. What do? I don't have any more single ones, right? Single pennies to add the 8. What do? I have a dime. I have 10 cents. It's the same concept. I have 10 cents. I'm going to trade it in. I'm going to add 10 cents. But guess what? I need to exchange it. Thank you, Jeffers. I need to take away the 2. I need to take away the 2. So my final answer is a 12. I can do it again. I can show you on the abacus. I add the 10 and I take away the 2. My final answer is 12. You are the only person teaching this. Oh, thank you. If I'm the only person. No, actually, I'm not the only person teaching it. I'm the only person teaching it this way. I try to relate mainstream math to abacus because I feel like this is the greatest thing next to sliced bread and it should be taught into school, American schools. Canadian schools. I believe it should be taught everywhere because I feel like it is a lost tool. It is a lost tool. Why isn't the 2 blues? Oh, that's a good question. That's a good question. So here's the thing, right? Where's my here's the thing. 1, 2, 3, 4, right? And then what happens? This is 5. If I have 5 and this is 5, what do I get? I get 55. Does that make sense? Because we're looking at every number, not the. Does that make sense? This is what 10 looks like. 1 and 0. 1, 0. Not 5 and 5. Right? So if we did this, where's my. Yeah. If we did this, we look at the actual number itself. So this would be the two blues, because it's 5, it would be 55. That's why. Just like this. This is 959. So when we're looking, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do the same thing. 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4. 5, right? 6, these are all 6s. 7s, these are all 7s. 8, these are all 8s. And then 9. These are all nines. Yeah? Did that make sense, Candy? Cool? That's a good question. It's funny though. It's funny because people do that. People always think that this is like this would be 5 plus 5, but it's not 5 plus 5. That's you. There's a formula to this, and we're gonna get to that right now. Because why? We're gonna add the 10. When we add the 10, that's what we need to do. Is we need to understand formulas. The formula that we're trying to understand is what we know how to make a 10. If we're trying to make a 10, right? If we're trying to make a 10, thank you, Melinda. Yes. So if I want to add, if I have 6, right? And I want to add the 5, just as Melinda said, what do? I have 10 cents. I'm going to give you my 10 cents. I could show you on my abacus. I'm going to give you my 10 cents, but that's too much. I need change. So I need to take away the 5. Okay, Jeffers. Thank you so much. Colloquial. Thank you so much for the reminder. She's a math wizard with this abacus. I'm not. I'm not a wizard. I just know, right? It's just I've been teaching this for 20 years. I know how to count from 0 to 9 very well. Oh my god. Oh my god. Oh my god, Melinda. I made this automation. It's so cool. And I can spit out my multiplication table really fast. Okay. Right? Right? I can count really well. I can tell you how to count to 9 very well. Okay. So that's what we're doing. And what we did here is why? Why are we doing it? Because we're looking at the abacus and we're looking at the constraints. We look at the restrictions that we have. And so now what we do is we do critical thinking. Why? Why are we going to do critical thinking? We have conversations with our numbers. We have conversations with our questions. So what happens is now we're going to critically think if we can do it. Right? Cool. I want to. Oh yeah. I have to. Yeah. Now you're a wizard. Do you lady? Okay, okay. So if that makes sense, what's going to happen is now we have our 10. We want to add the 10, take away the 5. People are like, that's too complicated. It's not complicated if you understand that we're teaching kids how to make a 10. If we're teaching the kids how to make a 10, I could show you on the abacus. So what's going to happen is what? We can do the 4. We can do another 8. So here we do 7. We have 7 on the abacus. We have 7 on the abacus, right? We have 7 on the abacus. And I want to add the 8. When I add the 8, just as Jeffer says, I want to add the 10. But 10 is too much. So here on my abacus, I want to have 7 and I want to add the 8. 10 is too much. So I need to take away the 2. So I need to take away the 2. And my final answer is 15. Man. So man witch. Well, just like male nurse, right? Math witch. Right? Thank you. Thank you, Melinda. Okay, okay. So what's going to happen, right? When we look, we understand how to add the 10. So the question we had was what? We had this question. 7 plus 9. When we have 7, where's my 7? 7 plus 9. We have 7 and then plus the 9. That was the question. We have 7 and we want to plus the 9. How do we plus the 9? Guess what? We're going to add the 10. That's too much. When we add the 10, that's too much. We got to take away the 1. So we're going to add the 10 and we're going to take away the 1. And my final answer is 16. You guys are so funny. Does that make sense? I think it was Adina that asked the question, right? Is that all right? Did that make sense? We can do it again. So if I have 8 on my abacus, right? Here's the question. I have 8. I have 8 on my abacus, right? Ooh. I want to add the 9. When I add the 9, there's not enough. So what do? I have my 10 cents. I'm going to give you my 10 cents, but that's too much. I'm going to take away the 1. So I have 17. I can show you on the abacus. I can add the 10 and I take away the 1. What did I just do? I just did some modification. I did 1 plus 9 is equal to 10, right? Right? Makes sense? So thank you for everybody. in. Welcome, welcome, welcome. Hello, Mel. Welcome, welcome in. So what we're doing is we're reading the abacus. So before we do, let's do a little review on how to read the abacus. So when we're looking, Mel, we're going to count one. So if I have one, it looks like this. This is one. That's what one looks like. If I have two, that's what two. You know that these are pennies, right? I'm assuming that you know these are pennies. I'm going to assume that you know that these are pennies. I'm not trying to talk down. I just want to let you know that these are pennies because I don't know where you are in the world. And in America, pennies is 1 cent. I'm sorry, I forgot to tell you 1 cent. So I have two. This is three. So I have 3 cents. And then I have four. This is 4 cents. So what do? Five is this. 5 is 5 cents, right? This is a nickel. A nickel is like that. So this looks very similar. This is 5, this is 5. And then we have 6, so I add 1. That's 6. Then we have 7. This is what 7 looks like. This is 8, right? Now we have 8. And then we have 9. This is 9. And then guess what? What do we have? We have 10. 10 looks like this. 10 is a 1 and a 0. 1 and a 0. 1. 1 and a 0. Thank you everybody for the compliments. Thank you so much. So when we look at 10, we have 1 and a 0. So let me know if you have any more questions, just like our place values. So every column is a place value, just as Melinda said. So when we look at it, we have ones, tens, hundreds, ones, tens, hundreds, thousands, and then 10,000. Cool? Cool. All right, so let's do it again. We can do it again. I want to add the 9. We're not memorizing. No memorizing doubles. What we're going to do is we're going to memorize our concept, right? We have that concept. What do? Remember, when we add the 9, we want to add the 9. What can we do? We know to add the 9, to add the 10 with the 9, it's 9 plus 1 is equal to 10. We do some... We're going to isolate the variable. 9 is my variable. We're going to do plus the 10 minus the 1. Why are we doing that? Right here. The question is right here. So if I have 9, I have 9 on my abacus. I'm going to do 9 on my abacus. And then I have another 9. Because we have another 9, I only have a dime. I only have 10 cents. I'm going to give you my 10 cents, but that's too much. I'm expecting change back. I'm going to take away this penny. I'm going to take away this 1 cent. Because I did that, I can show you on the abacus. I can add the 10 and then take away the 1. And my final answer is, when I read it, it is now 18. Welcome back. Welcome back. Equivalent to one $10 bill. Yes, I got it. I got it, right? Listening and crocheting. You guys are funny. Yeah, right? I told you. Easy. Simple to use. Easy to understand. Right, Ethan? Simple to use. Easy to understand. We could do it again with the 6. Now, because we know the formulas, right? We know the formulas. When we do 6, I have 6 on the abacus. I'm going to do 6 on the abacus. I want to add the 9. Guess what? We compounded this concept. We add the 9 is what? Plus the 10 minus the 1. So I'm going to plus the 10, but that's too much. I'm going to take away the 1. I'm going to show it on my abacus. I'm going to plus the 10. I'm going to take away the 1. My final answer is 15. Right? That's it. That's it. You know what? This is the secret. Everything we add and subtract has everything to do with adding the 5 and adding the 10. That is the secret. I'm just letting you know. That's it. Everything you know. 1 a.m. Yeah, that's so funny. You guys, it's midnight math. Yeah. So everything you know how to add and subtract. Okay, you know what? Let's do it. Let's do it. Let's do another one. Let me show you how it scales. I will show you how it scales. If we did this one, let's do this one, right? I have 135. We know that this is 135. And then what are we going to do? We're going to add 243. So we're going to add 2. Can we add the 4? Can we add the 4? Can we add the 4? We know this. How do we add the 4? what do we do? When we add the 4, what are we going to do? Remember, if I want to have 3, I have 3 on my abacus. 1, 2, 3. I want to add the 4. I have a nickel. So what do? I give you the 5, and I take away the 1. So I'm going to add the 5 and take away the 1. And then what do? Can I add the 3? Yes, I can add the 3. So my final answer is 378. Right? So now what we just did is we just scaled it. We are able to utilize the same concept, but now with bigger numbers. And that's the secret. The secret is we're adding and subtracting the 5 on every specific column. Any column you provide, you should be able to add and subtract anything now. If that makes sense. It's so much fun learning from Thank you, Melinda. Thank you, Candy, for the rose. Right? Okay, so that's adding. We can do subtraction. How are we doing? What's next? How are we doing? Do another one. Do another one. Okay, I'll get you another one. Let's do another one. All right. We did that one. We did this one. This one will be easy, right? So we have 26. And then what do? We add 32. Add the 3, add the 2. Can you add the 3? No, we cannot add the 3. But guess what? You can kinda. What do you mean? Well, remember what we did. Remember when we add the 3 is what? Plus the 3 is equal to plus the 5 minus the 2. Plus the 3, right? Plus the 3 minus the 2. And then we want to add the 2. We add the 2. And that's it. Thank you, Melinda. We need more practice with 3-digit regrouping. Is that what we're doing? Yes? Okay. Okay. That means I gotta write up my questions. I gotta write up my questions. I didn't do 3-digit. I can do 2-digit. Nah, I'm kidding. I just gotta find my questions. Hold, please. Let me regroup. Let me regroup. Okay. So we can do both. All right. So the regrouping is what? Regrouping just means what? It's adding the 10. That's all it is. Yeah. Thank you, Michaela. Yeah. So, oh yes, thank you, 58. Thank you so much. Okay, yeah. Hold on. Let me go get my questions. The reason why is because yeah. Let me hold, please. I need to find my because I don't want to be too. Oh, there we go. Here, easy. Okay. Let's do this one. Okay. Got it. Okay, let's see. You need the sound effect for the whole thing. What you do with this game, but I don't. Okay. 6 times. No, Jihad. We 6 times 2. The idea for that is you'd be additive. No, sorry, that's the wrong one. Oh, sorry. Additive addition. 1, 2, 3, 4, 5, 6. That's what we would do. 1, 2, 3, 4, 5, 6. Or we go 6 times 6. That's what we would do. That's how we would do it. That multiplication has to be more than a single digit. So the first number we're going to do is this. We're going to do 6417. All right, that's it. Okay. I know. You're so. Okay, we got 64. We're going to add 60. We add 4. Then what are we going to do? We're going to add the 1. What we're doing is we're plussing, right? Sorry, plus. We plus the 1. We add the 7. When we add the 7, what are we going to do? What are we going to do? Add the 7. When we add the 7, we know what? Plus the 7 is plus 7 and 3 is equal to 10. We're going to isolate the variable. When we isolate the variable, we know we're going to plus the 10 minus the 3. When we plus the 10 minus the 3, what did we just do? So the 7, we understand is 7 is equal to plus the 10 minus 3. Does that make sense? So what we just did, we did it again, right? plus the 10, 1, 0, 1, 0, 1, 0, and then minus the 3. 1, 2, 3. Take away the 3. Okay, multiplying is easy. Yes, thank you, Malaka. Yep, Malika. Yes, 81. So, Angelica, thank you for letting me know that you're new here. Yes, thank you. So what we're going to do is we're going to do a review for those that just joined in because we're at... Okay, 1, 2, 3, 4. Yep, Malika. Okay, good. 4. Anytime the beads are touching the horizontal bar, it's being counted. So we have 4. What happens to 4 is 5. The top bead is 5. Because I'm at 5, I can add this. That will be 6. Every bottom bead has a value of 1. So we have 5, 6. We have 7, 8, 9. After 9, we have 10. If Angelica is not here, we're going to move on to multiplication. But if she is here, if Angelica is here, please stand up. Okay, good. So does that make sense about place values? Oh, yeah, that's a good idea. So here's my place value. So every column is a place value. We have our ones, we have our tens, our hundreds, our thousands, and our 10,000s. So when we're looking, this is 10, 1 and a 0. We can do 55. We have 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. That's what 20 looks like. Yeah. So we go back to here. So we have 64, 64. We add the 1. We add the 1. Yeah, not a problem, Angelica. We add the 1. We're done, right? We want to add the 7. Add the 7 is what? Right? Oh. I live very close to the main street. So we have 7. When we add the 7, what are we going to do? Plus the 7 is what? Plus the 10 minus the 3. Plus the 10, 1 and 0. 1, 0. We know what 10 looks like. 10 looks like this. We're adding the 1. So when we're looking, we want to add the 1 and the 0. 1, 0. And then we have to minus the 3, right? Minus the 3. Oh, that's not nice. And we take away the 3. Does that make sense? So what do we have? We have 781. What we just did is what? We just did a plus 10, carrying over, right? Carrying over, or what do you call it? Carrying over, trading, regrouping, not as useful for the brain to use screen. Yeah, exactly. Exactly. The idea for abacus is to do brain gymnastics, right? It's just to use brain gymnastics and to keep us on our toes, and to be able to critically think the numbers that we have. So when we're looking, right, we want to understand, can I do it? Yes, I can, right? How do I do it? So this is one of the things is you need to understand is the formula. We understand this concept. So we have 98, no, 90, that's 90, this is 8. 5, 6, 7, 8, I'm sorry, 5, 6, 7, 8, 9, 98. 5, 6, 7, 8, right? Can you do one with a plus? Yeah, we could do that. Hey, Kay. Yeah, does that make sense, Ned? So when we're looking, right, this is 90, this is 8. We have our place values. And why are we here? We're here because, yeah, Ned, not a problem. Right here is because I have a ones indicator. There's this one and there's this one. If I want to choose this one, then I move everything over, right? And I could do 90, 98. right? But then I don't have any more columns for hundreds, and I don't have any more columns for thousands. Yeah, the place value card helps. Funny. Okay. I don't know. I guess it's because it's familiar to me. All right. So what are we doing? We did this one. That's what we're doing. Okay, cool. They didn't learn to count back change. That's an easier way. There's a reason why so many clerks. That's true, huh? Yeah, that's true. They punch it through the register and they hope the register is correct. Yeah. Yeah, yeah, it is different. Okay, okay, we want to do 3 digit. All right, 3 digit. We can do 3 digit. Let me find my 3 digit. All right. So we have we'll do this one. Okay. So we have 258 plus 424. How about that? Yeah. Okay. So yeah, I mean, abacus would have taught them. Yeah, exactly. Yeah, exactly. The fundamentals of abacus. Abacus is really good about the fundamentals. Okay, so we have 258. 258. When we add 424, we add the 4, we add the 2, we add the 4. Can we add the 4? No. What do we do? We know how to add the 4. What are we going to do? When we add the 4, yes, somebody asked if these were the smelly ones. Yes, it's the Mr. Sketch scented ones. All right, so we're going to add the 4. Plus the 4 is what? Plus 4 is equal to plus the 5 minus 1. So I'm going to add the 5 and I'm going to take away the 1. And then I need to plus the 2. Right? Plus the 2. Plus the 2. Can I add the 2? Yes, I can add the 2. Now I'm going to add the 4. When I add the 4, what am I going to do? Plus the 4. This is the great one. There's a workflow that happens. Can I add the 4? Is there enough beads to add the 4? I want to add the 4. I'm right here, right? I'm right here, adding the 4. Can I add the 4? No. Can I add the 5? No, because I'm already using it, so I cannot. I need to go to 10. I need to plus the 10 minus the 6. So I'm going to plus the 10, take away the 6. And so my final answer is what? What did I just do? I just did a grouping. So my final answer is 6, 8, 2. Okay. I knew, yeah. People still use this even now? Yes. Add 500, take away 100. Yes. Yes. But we don't say 500, okay? What we say is 5 minus 1 because it gets really confusing if you put in the extra hundreds. The reason why is because I don't need to worry about my place values because my place values are already on the abacus. Does that make sense? Okay. I have a question. What's up? Why do you work from the first number and not the last number? The reason why I feel like it is 682, not 280, 600. So when the way we read it is the way I feel like it should be. I think, Miracles, your question is being filtered. Can we do this again slowly? Okay, yes. So we have 258, right? Then what are we going to do? Add the 4. Can you add the 4? Here is my question. Can I add the 4? 4 is the key. Yes. 4 is the variable. 4 is the variable. We need to isolate it. We need to add the 4 is plus the 5 minus the 1. So we plus the 5 minus the 1. Then what are we going to do? We're going to plus the 2. Can we add the 2? Yes, we're going to add the 2. 1, 2. And then what are we going to do? We got to go here. Add the 4. Can we add the 4? No. What do? We got to, oh, I didn't write it. Plus the 4. Can I add the 5? No, I cannot add the 5, right? So what do? I have to plus the 10 minus the 6. Plus the 10 minus the 6. Plus the 10 minus the 6. So what is my final answer? Does that make sense, miracles? So my answer is 682. The parts of 4 are 1.8. I don't know, Zika. That's above my pay grade. I'm doing until very last move. Yeah, you know why? Because we're going to plus the 10. When we plus the 10, we have to see plus the 10 is what? Remember when we add the 10? 1, 0. Oh, it's lovely here. Okay, have a good night, Melinda. Thank you so much for stopping by. Have a good night. It is late. It is late. Okay. Does that make sense, miracles? So when we're adding the 10, it's a 10, 1, and a 0, right? So the question is what? 6, 7, 8, right? Is that right? Yeah. So when we add the 10, it's a 1 and a 0. Oh, thank you, Miracle. Sorry, I'm reading. I'm not frozen. I'm reading. I get it, but yeah, I know. In the U.S., we do ones first. You could go backwards. Like to me, I feel like it's backwards. So you could do 8. Oh, sorry, that's 8. So we do 10, right? Add the 10, take away the 6. You could do that. Add the 2, and then add the 4. Add the 4 is plus the 5 minus the 1. You could. I'm not saying you can, but you could. Right, Candy? Does that make sense? But yeah, I'm still here. Okay. Zika, if you're not going to be specific about abacus math, then please move on to another room because you're just wasting my time and spamming everybody, right? So, does that make sense, Candy? Good to be flexible. Yeah, you could go either way. I go left to right, but you could go right to left. You just got to keep track where your numbers are. That's all. That's all. But yeah, yeah, it's very good to be flexible, and that's the point. The point is to be as flexible because you have a system, you have a tool, so you should be able to use it backwards and forwards. Yeah, I'm getting it. Oh good. Oh good. But yeah, I mean, if we go that way, you could go that way. You could go, yeah, left to right, right to left. Sometimes I go left to right, but because I've been teaching abacus for 20 years, I go from left to right. And that's the body. The books, buying the books for me and my kids. Oh, that's awesome. That's true. We did right to left in school, then we carry over and stuff. Yeah. See that I think when we do the carrying over is it gets you really have to keep track of things. And I feel like that when we do the carrying over, then I feel like you have to like backtrack. Okay. So my computer's well. Yeah. Is there a left-handed version of this? The left-handed version would just be this, and you just use it with your. You would still need to use your right hand. So when we're looking, even though if I'm your right-handed, you're only going to be writing with your left hand, but you do calculations with your right hand because calculations happen to your left hemisphere. So that's why you still want to use your right hand to do the calculations. Does that make sense, Sean? But yeah, some people ask about that, and it's fine that you're left-handed to do this, but you don't, because you don't do calculations with your right hemisphere. You do calculations with your left hemisphere. That's why you do it with your right hand. Ideally, you could do with both hands if you wanted to. Yeah, you could. It depends on what how you want to do it. Am I a stickler on it? No. No, as long as I feel like as long as you get the idea of the abacus and you know how the beads move, I think it's fine either way. Is that the right hemisphere? Yeah. The right hemisphere is for art and for theatrical and so forth. The left hemisphere is for the calculations and yeah. Can we do one more like this? Yeah, we can do one more like this. So we'll do this one. There we go. Okay, we have this number. This one will be a little bit more. Why? Because we have 3, 8, 4 plus um, 8, 5, 9. Wah! All right, let's see. Hold on, you taught this for 20 years? No, I haven't taught it in elementary school and middle school. What I did is I opened up, my dad opened up a learning center out in Monterey Park. So I'm in Monterey Park, and my dad opened up a learning center, and I've been teaching abacus for 20 years. I have 3 boys, and they've all gone through the abacus curriculum, and I feel like it's the gateway to complex math. And so when my boy started going through algebra, he's like, "Wait a minute, I know this." I'm like, "Yes, you know this because it's very similar to abacus." And so what I noticed in abacus is we don't relate mainstream math terminologies to the abacus world. We have our own set of vocabulary. So what I'm trying to do is I'm trying to bridge the two together so it's easier to understand what we're trying to do with abacus and how we do it in mainstream math. Okay. So, I'm sorry. Does this link come with the device that you have? What link? I don't know what link. Um I'm left-handed but loved the math in school and failed art. Abnormally, yep. No. Okay. Is the feeling doing variables of algebra? Yes, it is very similar to algebra. Um, this one I have this abacus if that's what you're looking for. I don't know if somebody was looking for an abacus. Okay. So it's very similar to algebra, and then when we start doing long division, I heard it's very good for polynomials. Oh, we're doing this. Okay. So this specific one, right, is this one. Okay. So we're going to do 384. Right. And then we're going to do plus the 8. When we add the 8, what are we going to do? We know how to add the 8. To add the 8, what's the formula to add the 8? Ugh, a link showed up at the bottom of your life. Oh, the link. Oh, you know what? That link is if you want a free worksheet. I give you free worksheets. I will send you, if you send me a DM, just let me know that you are interested. I will send you a free worksheet, and it's a reference. It's a reference sheet to the abacus. There is books in my TikTok shop, but if you want the reference sheet, that will take you to, provide me a, I will send you, it will give you a DM. Just let me know that you're looking for an abacus, and I will send you the link to sign up for the worksheet. If that's not complicated, it's just a different way that TikTok is trying to promote conversations. And so, if you're looking for a worksheet, this is the worksheet. It's like a reference sheet, and yeah, not a problem, Jen. Thank you for asking. And I'll give you this. It's for free. The books themselves are in my TikTok shop. Okay. So then we have 8. When we have 8, we know this. We know we're going to add the 8 is plus 8 and 2 is equal to 10. So when I look, I'm going to modify it. I'm going to isolate the variable. What variable? It's the 8 that we're looking at. So when we look at the 8, we want to plus the 10 minus the 2. So 8 is equal to plus the 10 minus the 2. So I'm going to plus the 10 minus the 2. What? Yes. What did I just do? So I want to keep on this specific column. I'm going to plus the 10 minus the 2. Plus the 10 minus the 2, right? Plus the 10. So plus the 10 minus the 2, right? And then what I'm going to do, I'm going to add the 5. How do you add the 5? We know how to add the 5. We know how to add the 5. How do we add the 5? We add the 5 as what? 5 plus 5, right, is equal to 10. Plus the 5 is equal to plus the 10 minus the 5. So what are we going to do? We're going to plus the 10 minus the 5. Plus the 10 minus the 5. And then we need to plus the 9. So when we plus the 9, we know what? Add the 9 is what? Plus the 10 minus the 1. So what are we going to do? Plus the 10 minus the 1. Plus the 10 minus the 1. Plus the 10 minus the 1. That's what it is. 9 is equal to plus the 10 minus the 1. So, do you have a package deal so I can buy the abacus and the books? I am trying to figure out how to do the package on TikTok, and I can't figure it out. Because I know I can do sets, but yeah. That was cool. Thank you. Yes. Thank you, Jihad. 1, 2, 4, 3. But notice, right? Notice we just need to understand this. And then now everything is possible. Doesn't matter. Everything is possible. You just need to know it. Can you do base? Oh, yeah. Okay. Puzzle Mom. Hello. I enjoy your life. Thank you, Miracle. Everything works off. Yes. Yes. I'm telling you, everything works off the 5 and the 10. It's amazing. It is amazing. Hands down. Okay. Hello, Puzzle Mom. Here we go. Let's do a review. So we do 1, 2, 3, 4. Oh, you know what? I have this. There we go. There we go. 1, 2, 3, 4, 5 is always the top beat. The top beat is always 5. And then we have 6, 7, 8, and then 9. It's how, yes, exactly. It's how metrics should be. It's how imperial should be. Puzzle Mom. So when we do 10, 10, if you notice, is a 1 and a 0. 1, 0. So when we look, we have 1 and then 0. That's it. That's what 10 is. 1, 0. We can do 11, 12, 13, 14. And then we do 15, 16, 17, 18, 19, and then 20. That's it. You all right, Puzzle Mom? Does that make sense? Right, Jihad? I'm telling you, you know how to add the 10, you know how to minus the 5, add the 5, everything is done. I've never been so happy to learn math. Right, Candy? It's so awesome. Yes, I'm just so happy when people find this interesting. You know what I mean? Oh, thank you, Sid. Yes. The reason why we go to the middle is because it's just like a Pokemon. Pokemon, like if I do this one, then we can do this. We could do 1, 2, 3, 4. That's 4. And then we do 5. And then we have 6, right? 7, 8, and then 9. Now what happens? Well, we can do 10. Not a problem. I gotta find my paper. There we go. 10. We have 10. Right? When we do 10, it would look like that. That's 9. This is 10. But notice now I have no more rooms for hundreds and I have no more rooms for thousands. So then what happens? Then what happens is I need to go here. So if I go here, I'm going to move everything over. From here, I move everything over. So now I have the tens, thousands and the 10,000. So I have my ones, tens, hundreds, thousands, 10,000. So when I look, I go 9 and then 10. 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, cool. Never mind, answer that. When you sudden jump left to right, yeah, I try to stay in one side, but depending on who's asking the question, know that there are two indicators. Forgot about the hundreds and the tens. Oh yeah. So here, if you notice, we have the tenths and then the hundredths, which is the decimals. Yeah, we even have more columns too. Yeah. So we can do, right? We can do a 13 column one, and it's still the same concept. You just need to choose one dot, right? You just need to choose one dot. Or if you really wanted to, and you want to track the national debt, we have this one, which is a 23 column abacus. This 23 column abacus works exactly the same. It's just now it's 23 columns. That's all. This one is made out of bamboo, and this one's been with me for 20 years. These ones are made out of plastic, and this is what I'm selling in my shop. So here, right here, it's exactly the same, and it's you just need to be gentle. You don't need to be delicate because it's made out of plastic, but you do need to be gentle when you move the abacus because it's like a rattle, right? It's very easy. You bump it and then your answer becomes wrong. So yeah. Yes, thank you. There's the heavens beads and then there's the earth beads, if that's what you're asking. Points heaven to the right. I have a left squirrel with me. Yeah, I'm back. Hey, I don't know how to be famous. Welcome back. Ah, how are things? I don't know. I don't know. Okay, so that's we can do another question. We're ready for another one. So that's a 3 digit. We can do another 3 digit, but if you notice, right? Okay, I'm getting it slowly. Okay, so oh, that's right. That's right. Yeah, it's a miracle. That's right. Yes. Okay. Zika, I'm going to have to mute you if you're going to continue on talking about politics because we're not here to talk about politics. You do one more, I'm going to have to mute you. Or you can just leave. It's up to you. Okay. We'll do, yeah, you want to do another one? We can do another one. Uh, let's do, okay. This one is an interesting one. So, Puzzle Mom, hopefully you can hopefully this will be okay for you. We're going to jump ahead. There's actually been there's a few formulas that we need to understand. I'll take it slow, but as long as you keep your mind open. You want to try subtraction? Yeah, we could do subtraction. That's not a problem. Or some multiplying. Let me do one more. Let me do one subtraction and then we can multiply. Sorry, I'm thinking. Okay, 491 take away 49. Let's try that. This is the most supportive math class I've ever attended. Does anybody know where that came from? What movie that came from? Oh, oh, excuse me. This one came from. Oh wait. Okay. So what are we doing? Everyone actually wants to learn. That's why. Yeah, yeah. But I don't want people to say that they're dumb because they're not. Right? It's what it is. Is it's unfamiliar. Right? The more you do it, the more you become familiar. The easier it becomes. It's just like playing the piano. So we have 491. We have 491. Um, Now what are we doing? We're going to take away the 4. Can we take away the 4? Yes, we can take away the 4. right? We're going to take away the 9. How do we take away the 9? This is where it's going to get cool. Why? Because, oh, I got that. Why is this cool? Thank you, Jihad. But this is going to be cool. Why? Because now what we're going to do is we're going to Tetris our way through. What does that mean, Lynette? Okay, the first thing we're going to do is understand what? We're going to add the 9. Plus the 9 is what? Minus the 9. Minus the 9 is minus the 10 plus the 1. We're going to rewrite this, right? Let's rewrite it. We do minus the 9 is equal to minus the 1 plus the 10. Why am I going to do that? Because I want to minus the 1, right? Because where am I? I'm right here. We have 400, right? We took away the 4. We're here. We're going to take away the 9. When we take away the 9, what are we going to do? We're going to minus the 1 plus the 10. So we're going to take away the 1. We're going to take away the 1, right? We can see that. We're going to take away the 1. Oh, sorry. There we go. Take away the 1. And now we need to plus the 10. Plus this 10. Remember what 10 is. Oh, I guess this is right. Plus the 1, plus the 0. Plus the 1, plus the 0. Plus the 1. That's wrong. No, I'm sorry. That's wrong. That's wrong. Minus the 9 is equal to minus the 10 plus the 1. We need to plus the 1 equal minus the 10. That's what we need to do. I am so sorry. That's my fault. I'm a little tired. Okay. So we have 4, 1. That's what we're doing. So we're back to here. This is what we're doing. This connects to that. Okay, sorry. I apologize. So we're going to plus the 1 minus the 10. Plus the 1 minus the 10. Plus the 1. The first thing we're going to do is we're going to plus the 1. That's what we did here, right? And now we're going to go here. We're going to minus the 10. Minus the 10. Guess what? We can't minus the 10, but there's another way. To minus the 10, what do we do? Minus the 10. I'm sorry, 1. Okay, this is my last question. We'll do one more question, which is multiplication, but I am going to end the live because I'm getting tired and I'm making mistakes and it's confusing people. And I don't want to confuse anybody when I'm tired. So minus the 1 is what? Minus the 5 plus the 4. Minus the 5 plus the 4. So what is our final answer? Yeah. Does that make sense? What did we just do? We took away the 9, but this right here became a two-step equation, but it's still similar. Is it 300? No, it's not. 400. 442. Yes, thank you. Right? 442. Because this is my two-step equation. I use this to get that. So every number has a workflow. You take one number and you go all the way through the workflow. Yep. So that's the answer. 442. Yeah. Okay. Okay. We're going to do one multiplication, but why didn't we just add one more to remove? We did add one more. We did this. We had to add the 1. But we need to take away the 10. Take away the 10, we're at a 5. Because we have a 5, we cannot take away the 10. So we have to do this. We have to minus the 5 plus the 4. That's why. So we're doing it twice. We have to add 1 and then take away. Yeah, that's the 9. Yeah. See, this is connected. So when we're looking, it would be minus 9 is equal to plus 1 minus 5 plus 4. That's what we did. So this becomes that. Yeah. But see, that's the thing. We added the 5, we added the 10, and there goes your algebra. Yes. So what we did is we substituted, right? And then we do two-step equations. Because we do two-step equations, and then it leads into more algebra, which makes sense, right? But that's the thing. Like it slowly goes into, yeah. Well, not literally, because why? Because we're working with known values, right? We know how to do it. We have this value, right? Yeah, exactly. There's no x and no y, but you could, right? You could. But yeah, but it's just arithmetic. Funny, right? Solved equations. Yeah, like reverse algebra. I used to come to my answer, but hard to work. Showing work. Yeah, yeah. And that's the one thing is understanding how. But I don't know. I think it goes back to like trying to understand what we're trying to accomplish. And I think in school, mainstream school, they do all these strategies, but they don't leverage the bigger concept. This would have helped explain my brain to the teachers. Yeah, I think I'm too tired to understand this. Just what happened. Yeah, this one's a little bit more intermediate because it's also two step. But don't forget, Adina, don't forget, you just started, right? Like I've been on for about an hour and a half, and you just started getting into like a lot of things. Here, let's go something a little bit simpler, and I'll show you this, and then we will, and I'll end the live because I'm getting tired. I'm starting to feel it. Okay, here, let's do one more. Guess what? It'll be multiplication. Multiplication! I will show you how easy it is. Somebody said jihad. Oh, jihad. Jihad. That was funny. Okay, no, we'll do this one. It was so funny. Yeah, 6 times. Okay, so one thing is in abacus world, you need to know your multiplication fact. That's hands down. You need to know your multiplication fact. But once you understand your multiplication fact, it's very easy. The first thing we need to do is we need to understand where our starting point is. To find our starting point, we're going to do this one. 93 times that by 8. So we're going to count our digits 1, 2, 3. So we have 1, 2, 3. And then we do what? We do 9 times 8 is equal to 72. Add the 70, add the 2. Right? Easy. So then what are we going to do? Dread Pirate Roberts. Funny. So what do we just do? We did distributive property. We did that. Now we do 8 times 3. 8 times 3, thank you. 8 times 3 is equal to 24. Can I do it? Yes. Add the 2, add the 4. So my final answer is 744. Yeah, I'm telling you, it's easy because I can curate the questions. Yeah. But see, that's the thing, right? Like, once you know how to use the abacus, once you know how to read the abacus, then it is what it is. Yeah. Why did I start? Oh, because I counted this, right? 1, 2, 3. I know, right? It's helpful to think exactly. In mainstream math, we write it out 80 times this, 90 times 8. We write it out. But in abacus, we don't need to write it out. In abacus, we just need to put in 72. Notice it's 720. But what we did is we counted our digits. So we know that we're going to be here. 1, 2, 3. We know we're going to be here. Yep. We can do it again. 1, 2, 3, 4. 1, 2, 3, 4. What are we doing? We're doing 800 times that by 7. But instead, we just do 8 times 7 is 56. Right? That's all we're doing. Okay, hold on just a minute. So we did 56. Add our 5, add our 6. We're here. 5 times 7 is 35. Add the 3, add the 5. 5 times 3 is, sorry, 7 times 3 is 21. Add the 2, add the 1. Yeah, yep, thank you. Yep, I'm, okay. So the question is 93 times 81. Right? It's because I curated it. The questions are very specific. So this one may 83 times that by 81. So we're doing 4 digits now, right? 1, 2, 3, 4. We're here. 1, 2, 3, 4. We're here. 8 times 9 is 72. Add the 7, add the 2. 8 times 3 is 24. Add the 2, add the 4. Okay, now it gets a little hairy. Why? Because now we're going to be at, okay, we're done with the 8. We got to do this. We got to count. 1, 2, 3. 1, 2, 3. We're here. 1 times 9 is 9. 9 is a single digit, so what do? We go back 1 column. Or we can look at it as a 2-digit. 0, 9. 0, 9. We're going to add the 9. Plus the 9 is what? Plus the 9 is equal to plus the 10 minus 1. Plus the 10 minus the 1. We can rewrite it minus the 1 plus the 10. Minus the 1 plus the 10. Plus the 10. How do we plus the 10? Plus the 1 is equal to plus the 5 minus 4. Plus the 5 minus the 4. And then what do? 1 times 3. 1 times 3 is equal to 3. 3, again, double digit, 0, 3. There we go. So my final answer is 7, 5, 3, 3. Yeah. So, I mean, there's some more process that happens, right? Notice this was a plus the 10, and then this was a 2-step in here. Thank you for hosting the live. Oh yeah, not a problem. Not a problem. But no, I appreciate everybody joining and having conversation. I do enjoy conversations. It does help. It really helps to, see where everybody's at. Because I mean, I could do all these questions, but it doesn't help if you don't if I don't know that you don't know. Thank you. I now have a new reason to use TikTok. I'll be back for the next live. Okay, fantastic. See you guys all in my next live. Thank you so much for joining me. Looking forward for next live, and thanks for that. Yeah, not a problem. Thank you everybody for joining me. I do appreciate it. I do apologize for making mistakes. But once I make mistakes, I know I'm getting a little tired. But thank you guys for joining. Have a good night. And I will see you all. Will you be on live tomorrow? Yes. Yes. We all do it. That was great. Definitely a talent from teaching. Thank you so much, Jihad. Thank you so much. I appreciate that. What time? I'm going to try to come on 7 a.m. Pacific Standard Time tomorrow. Because tomorrow's Sunday. Tomorrow's Sunday. So I'll try to come on earlier. The reason why is because I have a class. I have a student at 9:30. So I'll try to see you at my 10 a.m. my time. Yes. Okay, cool. Oh my god, it's so late for you. You guys are nuts. You guys are crazy. Doing math in the middle of the night. You guys are so funny. Have a good night. Thank you so much, Jihad. Thank you so much. Thank you. It's almost 1 a.m. Yeah, it's only 10:40 for me right now. Thank you again, everybody. Have a good night. Have a good night. Bye. You guys, crazy.